Good morning, student. Welcome to my physics LCR class. Physics LCR class. Today we are going to see the electricity chapter. In this chapter, we are going to see the potential difference, resistance, and resistance depend on the factors. What are the factors? Resistance depend on the factors. That is 4 factors we are going to see. So in electricity, we should know about current, potential difference means voltage. We can say whenever we are buying the battery, how much voltage it is giving, 1.5 volt, 3 volt, okay, like that. Actually we are having a dry cells, it is a 10 rupees, cost is 10 rupees, it is giving 1.5 volt. Actually 1.5 volt, it is, we are saying a potential difference. I will explain what is the potential difference. We will see what is the potential difference. Then resistance, all the metals offers the resistance, that is we are going to see next. Actually resistance depend on the 4 factors. What are the factors we will see. First, what is potential difference? We can see potential difference or potential difference so that is we can say PD or voltage. What is potential difference? What is potential difference? So here we are having a positive charge body. So test body, generally we are saying a test positive charge. Actually it is bringing nearer to the positive charge body. So it is a test charge. It is a test charge. It is a very small distance, even though for the electron it is a long distance. It is a very infinite distance, we can say. So this test charge actually bringing nearer to the positively charged body. Positively charged body. So this position we are bringing the electron. Electron we are bringing in the book. Actually initially they found out. So that is actually positive charge they are telling. Actually it is not a positive charge, it is an electron, it is a negatively charged body. Okay, so but here we are saying a test charge is a positive charge. They told actually. Okay, this test charge we are bringing nearer to the positively charged body. This body, when this charge actually we are bringing nearer this position, actually we are bringing, some work should be done. Work should be done. Work should be done on the charge. Work should be done on the charge. So that is we are saying a voltage or potential. That is known as potential. Potential means the test charge actually bringing nearer to the charged body. Bringing nearer to the charged body. We have to do some work actually. We have to do some work. That is known as potential. That is known as potential. So we can say potential equal to work done by the charge. This is called potential. This is called potential. So that is we are saying a work done by charge. Work done by charge. Charge is capital Q we are denoting. Work done by charge, that is potential. So this is about, we are talking about the one terminal. Suppose we are having a 2 terminal. Suppose we are considering a cell. Just you see, it is a negative terminal, this is positive terminal. So what is the potential? Potential on this terminal and on this terminal. So the electron travel from negative terminal to positive terminal. So these 2 things actually, this is considering as a point, B point. What is the potential difference? What is the potential difference? So that time also the charge actually passes through the conductor. So here also work actually done on the charge. Work is done by the charge. Okay, so that's why, so potential difference. Potential difference means it is we are considering a 2 terminal. Positive terminal, negative terminal, any 2 terminals. Here I am mentioning A and B. Okay, so what is the difference? What is the difference, potential difference. So here also work done by, same thing it will come, work done by charge, work done by charge. Have you understood? What is the potential difference? What is the potential difference? Simply charge actually bringing nearer to the positively charged body. Test charge bring nearer to the, in the book actually vicinity, some vicinity means it is a nearer, we are bringing nearer to the positive charge, some work should be done. Okay, so potential equal to work done by charge, work done by charge. So potential difference means we are considering two terminal, positive terminal, negative terminal. So in these two terminal, what is the potential difference? Okay, so potential difference equal to work done by charge, work done by charge. So this is, we can say potential difference, no, it is voltage also we can say, voltage or voltage equal to work done by charge, work done by charge. Okay, so this is about the potential. Potential, what is the potential? The test charge bringing nearer to the charge body, some work is actually done on the charge, or we can say by the charge. Okay, some work is actually done. So that's a potential equal to work done by charge, work done by charge. So potential difference means we are considering two terminal, we are considering by the two terminal. So what is the difference between here? So that is called potential difference. That is also potential difference equal to same thing, work done by charge will come, work done by charge will come. So potential difference unit volt, potential different unit is volt, equal to, what is the unit of work done? What is the unit of work done? That is a, we can say joule by coulomb, charge, charge unit of charge is coulomb. So we can mention actually joule coulomb like this, we can mention. So that is a V equal to, so volt is a scientist name, volt is a scientist name. So he is actually, his name only is given actually, volt equal to joule per coulomb. So this is about voltage, this is about voltage. So here you can define 1 volt equal to, what is 1 volt? What is 1 volt? 1 volt defined as 1 joule work is done per 1 coulomb charge. That is, we can say 1 volt we can define. What is 1 volt? What is 1 volt? 1 volt equal to 1 joule work is done per 1 coulomb charge. 1 coulomb charge. So that is, we can define 1 volt. Okay. So this is about voltage. Next actually we are going to study about, resistance. What is resistance? So in electricity, here it is voltage, volt, current, I is a current, R is a resistance. These three things very important thing. So this is going to define one law actually, that is Ohm's law. You should know about potential difference, current and resistance. What is resistance? What is resistance? Suppose actually we are taking all the metals having a free electron, different material having a different number of free electron, So it is a proton. P is a proton. When it is not connected, we are not giving a connection, that is a cell connection or battery connection, we are not giving. The electron actually, it is a different direction like this actually. Different direction. Just you see. Different direction when it is connected like this. This is an electron. Electron actually going to hit when the metal actually connected with the cell or battery. Cell means single unit is called cell. One or more than two it is joined, no, it is called battery. So it is going to connect it. The electron actually moving from one particular direction. It is traveling one particular direction. Okay, this is a ordinary metal, the simple metal. In the simple metal, proton actually it is fixed, electron only it is moving. Already I told what is current electricity. Charges can flow. Electron actually flow from negative terminal to positive terminal. One particular direction it is going to travel. So this metal actually connected with the cell. So just you see, this is the negative terminal, it is positive terminal. When actually it is connected, immediately what will happen? All the electron, so it is just, I am giving it is a key arrangement. Just now you see what is happening. This is a electron. Electrons are, protons are fixed actually. When it is connected, I am giving a key, actually it is a key, actually it is a open circuit. It is not given actually here, a dot is given, it is closed circuit. It is a open circuit, it is a closed circuit. Now what happened here? Negative terminal to positive terminal, negative terminal. So electrons actually travel in a particular direction. Like this, it is going to travel. It is a electron going to travel. All the electron at a time it is not going to travel. It is constant movement is there actually. Slowly it is actually, not slowly, it is continuously. It is going to move from negative terminal to positive terminal. At a time all the electron is not moving. All the electron here actually some force is there, it is going to control. So the electron actually constantly it is moving. So it is called actually. So here what is happened? This electron actually going to hit on the positive charged proton. That means it is a proton. It is going to hit. So that's why what is happening? All the metal resist the movement of the electron. It is going to oppose the electron. So that is known as resistance. It is having a character, metals having a opposing character, resistive character. That is known as resistance. It is going to resist the motion of the electron. Okay. So how it is going to resist this electron? It is going to hit on the proton. Proton is actually fixed. It is not moving. It is not moving. Electron only it is going to move. Electron only it is going to move. So that's why actually here when it is going to collide, this electron going to hit on the proton. Okay, so that's why the motion of the electron actually slow down. Motion it is going to slow down. So that's why constantly the electron travel from negative to like this actually. This direction it is going to travel. So all the metals has the different amount of resistance. So all the metal offers the resistance. It is going to resist. It is resist means it is going to control. How it is going to control? The electron actually going to hit on the positive charge. It is going to hit on the positive charge. So that's why when the collision will be occur, it is offering, the metal offers the resistance. That is known as resistance. That is known as resistance. Have you understood? What is resistance? What is resistance? So all the metals gives the offering the resistance. So that is known about resistance. Okay. So now you can understand about what is the current, what is the previous class actually I explained what is the current. So now actually potential difference, this is about the resistance. This is about the resistance. It is actually metals, all the metals good conductor. Good conductor means it is having a less resistance. All the metals like actually silver. So the resistance actually we can say are. What is the unit of resistance? What is the unit of the resistance? Ohms. Ohms are, this is a omega, Greek letter, we can say it is a omega. So it is I written actually how to pronounce omega. So this is about unit of the resistance is ohms. Unit of the resistance is known as ohm or omega, we can say. Silver, next here you people know about silver, then copper, aluminum, this is a gold, aluminium, lead actually. So here actually silver having a more number of the free electron, it is a decreasing order it is given. So here actually decreasing order, Pb means it is a lead actually, it is a lead. Lead has a very less number of free electron. Good conductor, different metal having different number of free electron they are having. Bad conductor, insulator, number of free electron is very less, very least we can say. So good conductor gives resistance, very less resistance. Bad conductor, insulator, it is gives a more resistance. It is giving a more resistance. Okay. So now resistance depend on four factors. Resistance depend on four factors. What are they? Material, length of the conductor, area of the conductor, temperature. So these three things. These four things. Material, length of a conductor, area, temperature. Okay. So what is material? I told actually. Material, it is a depend upon actually silver, copper, gold, aluminium. So these are actually good conductor. These are having a different amount of free electron. So large number of free electron gives the less resistance. That is a good conductor give. Good conductor means it has a more number of the electron. It is giving a less resistance. Insulator, it is a free electron is least, negligible even though we can say. So it is offering a more resistance. Here I written large number of free electron gives less resistance. So all the metals having, here I written all the metals having a free electron. So it is producing or give a less amount of resistance. Second one actually, length of the conductor. The conductor is longer. It is a length of the conductor. It is a very long. So when it is a long, what is happen? This electron actually going to hit on the proton. And the collision will be occur. More collision will be occur. So that's why length is large. So resistance will also large actually. Because why it is happening? The proton it is negative charge, electron actually it is going to hit. Okay, suppose it is a small length. Okay, so what happened here? Collision will be less. Here collision will be less. Here collision will be more. So that's why resistance directly proportional to the length of the conductor. L is a length. R is a resistance. Here I mentioned R is a resistance. So directly proportional. Shorter length of the conductor gives a less resistance. Longer length gives a more resistance. So resistance and length of the conductor directly proportional. Next one is actually area of the conductor. Area of the conductor, that is inversely proportional. Area of the conductor, it is inversely proportional. The cross section is less. Area here actually I am mentioning area is small. It is a thin wire, a thick wire. It is here what has happened? Here actually area is more. What is the difference actually? When thin wire, that is when it is giving a collision, it will give a more collision. Okay. So here actually area is larger. So collision will be less. So that's why inversely proportional. Area is large. So resistance inversely proportional. Area means here actually small a we are mentioning. Inversely proportional. So thin wire gives area is less. Area is small. Area is less actually. It gives the more resistance. Here actually area is larger, inversely proportional will come. Area is larger, resistance is less. So area more, resistance less, inversely proportional. Here area is small, resistance is small. Resistance less means area is actually more. So it is a inversely proportional property will come. R is inversely proportional to the area. Next temperature. Temperature actually Here already written actually more number good conductor material. So here free electron number of the free electron is different. When you are increasing the temperature, pollution will be more. Pollution will be more. So that's why what will happen? Temperature increase there, pollution more. So that's why what will happen? Resistance also more. So that's why it will be directly proportional will come. Directly proportional. So temperature directly proportional will come. Increasing the temperature, pollution also increase. So that's why what happened? Resistance will be more. Okay. So temperature decreases. Okay. So resistance less. So that's why resistance and temperature directly proportional. Here actually number of the free electron more, less resistance. What is the relation between length of the conductor and resistance? That is also directly proportional. So larger length is large, it is giving a resistance, offering the resistance more. Length is actually shorter, resistance is also less actually. So directly proportional. Here resistance and area is inversely proportional will come. Resistance and area inversely. Here I given a diagram. Area is small. So that's why what happened? Area is small means resistance more will come. Here resistance more. Please note down. Here area is large. Area is large. What happened? Resistance. That's why we can make a relation. Resistance inversely proportional to the area. Resistance is actually inversely proportional to the area. Next actually temperature, it is directly proportional. Directly proportional. We are increasing the temperature. What happened? The electron going to heat also. It is also increases. It is also increases. That's why resistance will more. More pollution will be occur. More pollution will be occur. So that's why what happened? Resistance will be more. So that's why resistance and temperature, it is directly proportional. Directly proportional. So today we learn potential difference, unit of the potential difference, that is a volt. Otherwise joule per coulomb we can write like this. Next resistance, the capital R. What is the unit of resistance? Ohms. It is a symbol omega. Next resistance depend on the four factors. What are the four factors? Material, length of the conductor, area of the conductor, temperature. What is the relation here I mentioned actually. So here actually four things are given, but these two things very important. Next class we will see. Resistance directly proportional to the length of the conductor. L is a length of the conductor, A is a area. These two things are very important. So today I am going to finish my class. Thank you children. Just watch my video. Thank you. Thank you.